Okay, good afternoon, everybody. I make that 2 o'clock, and welcome to the CIRIA launch event for Geotechnical Baseline Reports, a guide to good practice. My name is Andy Moores. I'm the Research Director at CIRIA, and I'm just going to go through some elements of housekeeping first of all, before handing over to our panelists for this afternoon. So this webinar is being recorded. I've seen someone ask that question already within the chat, and will be made available to all those participants afterwards. You are all in listen only mode, which means that any questions that you wish to ask should be posted within the Q&A box. If you do have any problems, please raise your hand. We've got help in the background, and someone will endeavour to sort out any problems you might be having with the technology. Please do use the Q&A box. The chat facility is there as well, and we often get questions coming into the chat box. If you put them into the Q&A box, it allows myself and Tom, who is going to chair today, to curate those questions, and I would encourage you to put them in a timely fashion. A, it gives us a chance to curate them. B, it gives the author team chance to see them, and C, allows them to have a decent crack at answering them more coherently. If other questions that you see are being asked, you like them, please just give the thumbs up to those. That allows us to identify the most popular questions to ask and aids the Q&A session, which we're going to have at the end. There is a range of social media hashtags there and Twitter @handles. Please feel free to share your thoughts as we go. Just a little bit of background then about CIRIA. So CIRIA is the Construction Industry Research and Information Association. We're a not-for-profit member-based organisation, and really we operate at the interface between academia in terms of research and good practice on the ground, and we aim to provide knowledge at improving the performance within the UK and indeed further afield, built environment and construction sector. We do this through producing guidance, which today's webinar is about. We also have high quality training courses, webinars, communities of practice, and other channels which we would encourage you to seek out in terms of improvements in the sector. Just a word or two about our membership. We've got us approaching 80 members at the moment, and you'll see from the slide there, they are spread across a range of sectors, all the way from government departments, agencies of government, tier 1 contractors, other supply chain members, and also academic institutions in terms of universities. If you are interested in exploring further about CIRIA membership, please do get in touch. We're always welcoming, and we can outline some of the benefits that CIRIA membership will provide you and your company. None of our work is possible without funding, so the guidance that we produce is, if you like, sponsored by a range of organisations, and these are the funders that have contributed to the production of this GBR guidance. So a big thank you to BAM Nuttall, the British Geotechnical Association, British Tunnelling Society, HS2, Geotechnical Consulting Group, Fugro, Jacobs, Mott, MacDonald, and also National Highways. None of our work would be possible without the patronage of funding institutions. The guide itself is available now. It's on a preferential rate until the 9th of February. We will put a hyperlink in the chat box, which will enable you to click through straight to our bookshop. So please follow that and feel free if you like what you hear today. We're not going to go through the biographies of all of the individuals. We have biographies which we'll put in the chat as we go, but these are our speakers today. First of all, Tom Berry, who was the PSG chair, John Davies, Randy Essex, Anthony Drake, and Imran Farouk, all of whom contributed to the chapters. And as you will see, this is very much a collaborative effort, which extends far beyond actually the author team as well. Hopefully you've seen this in outline when you signed up, but in essence, we're going to take you through the context and the need for this guide, a little bit of the international perspective, the use of GBRs in a UK context, and then into the nuts and bolts of actually drafting a GBR using case studies and the application of GBRs to different types of engineering practice. We are hoping to have an interactive discussion and Q&A at the end. We're scheduled to finish at 3:45. We do have a 15-minute window if there's a need for an encore, if the questions are flowing. So please do put your questions into the Q&A box as we go. So without further ado, I'd like to introduce Tom Berry from Jacobs, who was the chair of our project steering group. Tom, if you want to put your camera on, and over to you. Thank you.
Hello everyone, thank you very much for that introduction, Andy. So as you know, we're here to talk about the Geotechnical Baselines Report guidance. As Andy mentioned, the GBR report has been written by a consortium from GCG and Mott MacDonald, who have extensive experience in the UK and internationally of writing such reports. So they really were an expert group, but they are only part of the team who are involved in the preparation of this report. There was a project steering group. So it really is important that we say thank you and acknowledge the work that the steering group has done to get this report to where it is today. As you can see, the steering group is composed of a number of individuals from both consultants and contractors, but in addition from owner organisations as well. This group of people and the input they had was supplemented by legal contractual support, and you can see the people there. We should probably particularly note the input from Richard Patterson, and then a number of informal consultees as well, who again supported the work that was done. As you can see, it's really, it's a really strong team of people who have been involved in this project, and they have great experience from a number of different GBRs across different countries and from different perspectives, owners, contractors, and consultants. I mean, it was an interesting and often quite lively series of meetings and debates that we had. Some robust and forthright discussions were had. And I hope in the end, the deliverable represents substantially the consensus view of the steering group regarding what the industry considers good practice. The authors and the steering group note the report is a guide to good practice, not necessarily best practice and not necessarily only practice. And so deviations from this guide might be expected. So I just want to talk briefly now about the original project brief. At the outset, the project brief was based around defining the purpose of a GBR and exploring the link with better management of ground risk. The original project brief also involved successful drafting of GBRs and providing guidance for what that might look like, and looking at different forms of procurement and how incorporating GBRs into different standard forms of contract might be achieved. The original project brief also looked at describing suitable standard forms of contract and ultimately providing guidance which was would enable that would assist clients in establishing the right balance of risk. There were variations as the project continued, and we got input from the steering group. So through early steering group discussions, the original objectives were refined. The key objective of the report is to establish a common level of understanding around the fundamentals of a GBR, as there remains some significant uncertainty, maybe ignorance, around what a GBR is and how it should work within the UK context. It's hoped that providing industry with a consistent but flexible approach, as outlined in the guide, will enable a comprehensive understanding of the ground risk and lead to better project outcomes. The guide will also address some of the shortcomings which stem from a lack of involvement by appropriate construction, legal and commercial specialists, and probably some poor behaviours from both clients in terms of risk shedding or lack of engagement, and from consultants in drafting techniques. Finally, there is a drive to encourage the use of GBRs across other scales of project and other types. GBRs are not just for tunnels. I've been very fortunate to be able to work on GBRs for piling projects, earthworks, bridges and viaducts. And they've been used successfully there. So next slide. Okay, so this is a really important slide. Okay, I'll let it hang there for a second and then I'll just read from it. The Geotechnical Baseline Report is a contract document, okay, containing measurable contractual descriptions of the subsurface conditions anticipated or to be assumed to be anticipated during construction. It facilitates the allocation of ground-related risk and commercial responsibility between the owner, the employer, and the contractor. An additional benefit of a GBR should be the efficient claims management process that it also delivers. So what is a GBR? Okay, briefly, a GBR is a commercial risk-sharing document comprising a set of baseline conditions. We'll talk about baseline conditions later. It provides a common basis for tenderers. It avoids high risk premiums, or the opposite, low bids from contractors who don't appreciate necessarily all the risks or are very hungry to win the work. It relates to construction, not design. You'll hear John talk about encounters later. We're talking about physical conditions encountered by the works impacting cost or schedule. And these are often subtly and sometimes starkly different from the design considerations. So what is a GBR not? It's not a risk reduction tool or can be used really to improve cost certainty. GBRs do not generally improve cost certainty. They can and should ensure a more optimal risk allocation based on which party is best placed to manage a given risk. But the risk is moved, not mitigated. It's not suitable for GI, but from a contractual perspective, it can fill certain gaps. It's not a technical document, okay? We said before it's a commercial document. Fundamentally, a GBR is a contract document, not a geotechnical report. The perception is that because the word geotechnical is in the title, the geotechnical profession, pardon me, should have a sole responsibility of the preparation, and that's not true. There'll be a nice slide later which shows a number of different people or disciplines who might or should, depending on the nature of the project, input into a GBR. And it's not intended to cover every eventuality. I mean, how could it? It would be flawed if it tried to do so. The value of the GBR is on focusing on the key risks and uncertainties and managing them. Okay. So, the core content of the GBR report. The first part of it is about the coverage, okay? So again, the guide defines things in terms of a project chainage or an asset name or a site boundary. It defines physically the area that the GBR covers. It also provides some really good, clear definitions. Lack of clear definitions can lead to ambiguity and subjectivity in what is supposed to be a document that provides objective clarity. So we've got to be super clear about the definitions, and then the baselines themselves. It's important to convey the intent of a baseline and to offer an explanation if a baseline has been set that maybe contradicts the data. This is to avoid misrepresentation. Baselines can take many forms, but they must be measurable and they must be unambiguous. And then there's the something about measurability of baselines, a method of measurement. Fundamental to an effective GBR during construction is having a simple set of measures so you can measure the baseline. They're often, but not always, neglected is a sampling frequency maybe, and the spatial distribution of tests to measure baselines. And finally, from me at this point, a little something about the CIRIA report structure and where the emphasis of the report might best sit with the different parties who are involved in the preparation of a GBR. So you can see that maybe the front end of the document about purpose and who should write a GBR and how the GBR relates to a contract definitely sits with the employer, the owner. And whereas when it comes down to the detail of the drafting and maybe the application, that might not be as important, still important, but might not be as important to maybe some of the front end stuff. The same with contractors. However, if it's the authoring team, then all of the elements of this report are important. So, and therefore the emphasis should be on all those sections. So it is with great pleasure that I can now hand over to Randy Essex, who probably doesn't need much of an introduction to those who work in GBRs. And he's going to now talk about the background of GBRs from an international perspective.
Thanks, Tom, and very much appreciate being with you all this afternoon. It's been a vigilant road that's taken us to this point. Why were GBRs created? Let's look at it in the context of the good, the bad, and the ugly. Let's talk about the bad and the ugly. It was precipitated primarily in the US, where perhaps we have more barristers per capita than anywhere else, or at least at that time we did. But owners had this attitude of, here's the data, you bid it, you build it, 100% full risk transfer. Contractors bid optimistically. They filed differing site or unforeseen condition claims. And when costs exceeded what they bid, and different bidders bid on different bases with different interpretations. So it was a terribly uneven playing field. As a result, there was an upward spiraling of litigation, which resulted in bad publicity for the owners and rather ugly financial outcomes for the contractors. They had to finance additional costs for years after the construction was completed. The US industry realized if we didn't change what we were doing, people wouldn't buy our product. They would turn to other means of conveying whatever they needed to convey without employing underground construction. And so a number of research projects were undertaken and a number of reports were published. Some of these are cornerstone documents that have global significance, but they began in the US, 74, 84. Underground Technology Research Council produced a number of documents on them. How do we avoid and resolve disputes during construction so that people will buy our product with some sense of confidence that they'll achieve their intended outcomes? 4 fundamental contracting practices were recommended as a result of this 2-decade evolution of work. A differing site conditions clause or a variations clause in UK speak. Some kind of a document that would set the tone for this is what the contractor is entitled to rely upon and we will use to administer that change conditions clause. Escrow bid documents by the selected bidder, that's where the low bidder is required to place in escrow confidential proprietary information in a bank and a third party so that if there is a dispute, the parties have access to that documentation to help resolve the dispute. And finally, a dispute review board, which was evolving contemporaneously with the development of GBRs. The industry said we needed further guidance on what goes into a GBR and what is a dispute review board. And in 1996, this document was published. This is the beginning of what is now known as the Dispute Resolution Board Foundation. You can find the current version of this manual on the web. And then I raised my hand in 1996 and said, okay, I'll give this a go. Let's pull together a committee and have some industry workshops and understand from the industry's perspective what needs to be fixed or what needs to be explained. And we published this document in 97. 10 years later, we produced the Gold Book, in 2007, and literally last month we've provided a third update and each of these documents has built primarily on lessons learned of good and bad experiences along the way. Well, what's the good? The good is that GBRs have not just been utilized in the US, which what was our concern, but it had extended in its application around the globe. This is just an indication of the different areas in the world that are using geotechnical baseline reports, because people are realizing disputes can upset the tone and delivery of lots of different projects: hydro schemes, water, wastewater, rail, transit, vehicular. And as this has evolved, there have been regional documents produced that help to put a spin on the local practice, of which the CIRIA publication is one, but one that I participated in as a reviewer was a document produced a couple of years ago by the New Zealand Tunneling Society on how they apply, or how they desire to apply GBRs and risk resolution and claims resolution in New Zealand. Other guidance documents have made reference to the use of GBRs, the Joint Code of Practice back in 2003, updates on an international perspective in 2006 and 2012, guidelines for improved risk management in the US. It's not a code, it's a guideline. And something that I was a participant in, a joint publication by FIDIC and an International Tunneling Association called the Emerald Book. It's a version of the Yellow Book for underground works, and it talks about a collaborative geotechnical baseline report development process so that both parties understand the content and have an opportunity to contribute to what the baselines will be that will form the basis for tender and resolution of claims. And as I say, our new CIRIA document is the UK adaptation for UK practice and UK forms of contract that take account of some of the international principles and lessons learned. So what are some of the principles? Fundamentally, it's no longer a matter of contractor, you bid it, you build it. We're attempting to obtain a basis for fair contracting where the owner pays a fair and reasonable price for what the contractors have to go through to build the facility through the ground and in the locations as dictated by the employer. Bidders can rely and will be responsible for the information in the GBR. It's no longer what they bid as a basis for claim. It's what was indicated to be the baseline under the contract. And the one benefit is that now all bidders tender the same risk profile. So we are attempting to level the playing field. Encountered conditions more onerous than those in the GBR and other contract documents may be compensable under the contract if the contractor can demonstrate that it reasonably relied on the information provided and that the more onerous conditions resulted in an increase in the cost or time of the work. So we look at this, we've got this description in the document that the GBR works in tandem. It's a technical document, but it's also a commercial document, and it has very significant legal ramifications. And in the center there, our focus is risk identification, risk allocation to the parties as they desire it to be allocated. And it's intended to be a preemptive means of mitigating claims. And if there are claims that do evolve, there's a dispute resolution process and tools to facilitate that resolution process. If the process works as intended, apologize to all the lawyers on the call, but we keep the litigators out of our business. Let's provide better contracting terms so that the employer and the contractor complete the work as intended for a fair price within the footprint of the construction process, not extending years following. So the look at the GBR is actually, it's a consequence or the outgrowth of a risk analysis process. In any project, we look at site investigations, we do lab testing, and whether it's a design build or a design bid build, we develop a reference design or a final design. We do a quantitative risk analysis of the likely events. Those are typically summarized in the geotechnical baseline report based on data in the geotechnical data report. And what it goes into the bid as the known knowns. That's what the contractor has been asked to price. Well, there may be other circumstances, obstructions, contamination, the number of hyperbaric interventions, let's say, where we know we're going to have these kind of conditions, but we're not assured as to the quantity. So we set baseline limits for costly items, and these are medium probability but high cost. And there's an opportunity to set aside provisional sums to deal with these known unknowns if and when those quantities in the contract are exceeded. This is perhaps the most important point, is that we then do a quantitative risk analysis of the unlikely events, the items that are not mentioned in the contract, they're not priced in the bid quantities. These are low probability, high cost. If we included them in the scope of work, one might perceive it to be a budget buster. But we do provide a contingency fund that is perhaps a 95% capture of the risk analysis that says, in the worst case scenario, these types of events could occur. We set aside a contingency fund that prices the addressing of those conditions. Those are the unknown unknowns. And we acknowledge that these can only be discovered during construction, because from first principles, we don't have X-ray vision. We do the best we can in the SI, but it's never complete. In both the provisional sums and the contingency fund, the owner or the employer pays for out of these funds only if the conditions are encountered that warrant their administration. Perhaps this is the most important disconnect that we're finding in a number of circumstances around the globe, is that owners seem to believe that pricing the known knowns in the bid is the basis for their budget, when in actuality, this entirety should be a basis for the budget, knowing full well that those second two categories, those smaller buckets, are administered only if and when warranted. I have found that having owners understand what a contingency fund is and having them participate during a process that helps with the quantification is an awareness adjustment that changes their levels of expectation if and when a dispute arises. I think right now that's the most important element in communicating out to the industry, how we can manage expectations amongst all the parties, and so that we avoid animosity if a condition encountered during the construction materializes. At this point, I'd like to turn it over to Anthony to talk about GBRs in the UK. Thank you very much.
Thanks, Randy. Yeah, so as Randy says, I'm going to switch our focus to the UK context. So firstly, I think it's useful to give a bit of an overview of the relevant history in UK practice, and we do this in the guide as well. So we start our journey all the way back in 1876, so the case of Thorne versus London Corporation. So this is one of the early precedent case laws, concluding that the contractor bears the risk of changed ground conditions unless the contract makes provision otherwise. And there are a number of other examples that have upheld the same since. Given that this is a CIRIA guide, it's noteworthy that previous CIRIA reports have picked up strongly on this theme of unexpected ground conditions and risk allocation. So a quote from the CIRIA R79 report in 1978. However unexpected the ground conditions prove to be, it's better to have a defined base for the tenders so that it is known where the incidence of the resulting cost will lie. And then in the next box, I'm highlighting that there are some high-profile projects with ground-related problems that got the attention, particularly of the insurance industry, and I guess to a degree invited scrutiny from government as well. And I'm perhaps unfairly picking the example of the Heathrow tunnel collapse. But following on from that, there were a number of government reports. So most people would have at least heard of and hopefully seen and digested the Latham and Egan reports. So Latham, in constructing the team, identified primarily disharmony and adversarial relationships as problematic. Egan, in rethinking construction, proposed more radical change, favouring the approach of partnering and aligning objectives between parties to the contract. And I think GBRs and our focus on equitable contracting, which sort of Randy has introduced, is wholly aligned with these reports. The GBR is a tool to facilitate a more transparent and collaborative allocation of risk, allowing the parties to focus on delivering the desired outcome. We then have the Association of British Insurers and British Tunnelling Society Joint Code of Practice in 2003. And this set out the requirement for tunnelling projects to set ground reference conditions. And around the same time, we had new reforms to the civil procedure rules. Now, these civil procedure rules govern civil litigation in England and Wales, and they expressly state that the court's duty includes encouraging the parties to use an alternative dispute resolution procedure. And hence, a lot of our common forms of contract in the UK typically have mediation and adjudication processes already embedded. And this is arguably maybe a key difference between the US practice and history that Randy has described and where we are in the UK. Projects since the Joint Code of Practice that have adopted GBRs include Crossrail, Victoria Station Upgrade, London Power Tunnels, Northern Line Extension, Tideway, and HS2. And usually they use a modified version of an NEC form of contract. And it was also noteworthy that GBRs on these projects have not just been focused on tunnelling, they've typically included piling, dewalling, ground treatment, and more recently earthworks as well. So moving on to look at the role of different parties in the GBR or in its preparation. Firstly, I think it's evident that in UK practice, the engineering consultants tend to be the party tasked with preparing these documents, whether on behalf of the employer or the contractor. However, it's only the employer and the contractor, if we set back-to-back agreements to one side for the moment, who will be signing up to the risk allocation the GBR proposes. So one thing we're clear about in the guide is the critical role played by the employer in setting the desired risk profile, and we highlight the danger of consultant-led GBRs without proper engagement by the employer. So we're talking here about scenarios where a consultant advises maybe a less well-informed employer that he should use a GBR without full knowledge and understanding of the implications. We also recognise that the contracting parties will sometimes have conflicting interests, allied to an employer's desire for cost certainty on the one hand, and a contractor's reluctance to accept poorly defined risks on the other. The roles of the party, of each party are explored much more in the guide, but I wanted to get on to talk about specifically who should be involved in authorship. Fundamentally, a GBR is a contract document, not a geotechnical report, which has been highlighted already. Project teams have a responsibility to ensure the right balance of experience and specialism is reflected in the GBR authorship, and that geotechnical specialists are not left to prepare it in isolation. And I think Randy has already alluded to the role of technical, commercial and legal disciplines coming together to create a single contractual document. And if you remember the graphic he showed, it had identification and allocation of risk, preemptive risk mitigation and dispute resolution as those common threads in the centre. So if that's the desired outcome, what good practice leads to this? Well, I think, but maybe in summary, clear and unambiguous allocation of risk, readily measurable on site and hence easy to implement, an understanding and engagement by the parties signing up to the GBR, so that's both the employer and the contractor, and a collaborative approach. I think the best GBRs will result from a process that includes dialogue throughout procurement to identify, quantify and agree a balance between risk allocation, tender price and cost certainty. So this, just looking at those three parties is a bit too simplistic, and maybe we have something more like this, which is a figure adapted from the guide. So for large complex projects, a team approach is required. Now, I think we've already said, and clearly some of the key people in authorship will be engineering geologists and geotechnical engineers. These are the people that understand the ground and the design intent. Knowledge of the ground prior to construction is always going to be imperfect. the hazards presented by this imperfection arise from physical gaps in knowledge, maybe physical gaps between boreholes, or from the inability of ground investigation techniques to fully characterise the nature of the ground. So the starting point for well-informed risk allocation should be the conceptual ground model, and then that is augmented by observation from ground investigation and testing, previous construction records and desk study, etc. And John will talk more about this in the next session. But so who else do we need? Well, procurement contract specialists, partly to advise on drafting unambiguous, concise baseline statements, and partly for adapting contracts to incorporate the GBR. We need people with detailed knowledge of the relevant construction techniques and/or equipment that's going to be used and what its limitations might be, for input to what could go wrong and input into practical measurement on site as well. We need clients to input their views on their appetite for owning risk, and we need the contractor, and the level of contractor involvement will maybe depend on the procurement arrangements, but a GBR can be far more beneficial to the project as a whole if the contractor is invited to comment on what baseline items are going to make a difference in terms of cost and schedule, and how those baselines could be most helpfully structured. So the guide provides much more detail around specific competencies, but the most important factor is relevant experience, and that's experience in using GBRs. We make the point that that's far more important than experience in writing GBRs, as only the former provides the necessary experience of the contractual nuances and also that practical implementation on site. Now, the guide is written in a contract neutral way, and therefore we've not attempted to cover the specifics of different forms of contract. There is, however, a useful appendix on guidance for integrating a GBR into the NEC engineering and construction contract, and many thanks to Richard Patterson for his input on that section. But these are the key generic points that the guide does address. So firstly, the GBR must be part of the contract, which in most cases will require amendment to the standard form of contract, the new FIDIC Emerald book, which Randy referred to being a notable exception. Two, the GBR also needs to link the exceedance of a baseline to the contract's mechanism for claims for additional time or money, and this is often relatively straightforward to do. Thirdly, because the aim is an unambiguous allocation of risk, the GBR must take priority over other potentially conflicting information in the contract, and many forms of contract will allow for a hierarchy of contract documents to be stated. The NEC is actually a notable exception to this, and the guide provides specific advice in the appendices for how to overcome that. Number four, one important point the guide makes is that a GBR cannot cover every eventuality, and therefore the contract should address how risk is allocated for conditions outside the scope of the GBR rather than remaining silent and therefore ambiguous. This might be by reverting to the standard foreseeability test in the contract. And finally, number five. Now, we had some healthy debate around inclusion of factual GI data in the contract versus provision on a for information only basis, which we've commonly seen in UK practice. In the context of the role of the GBR, the factual data becomes important for conditions that are not covered by the GBR. So without the backstop of a foreseeability test for conditions outside the GBR scope, then it follows that a contract with unforeseen conditions clause but no GBR could actually be a more equitable contract than one with an equitable but not universal in scope GBR and no unforeseen conditions clause. Put another way, if a significant unknown risk, which Randy referred to earlier, is realised but is not covered by the GBR, is it reasonable for that risk to be borne entirely by the contractor, as legal precedents would suggest when the contract doesn't state otherwise? Now, as we're not recommending you attempt to baseline everything in the GBR, we therefore also need to recommend a secondary foreseeability test and inclusion of the factual data to inform that test. So moving on to look at the timing of the GBR. A common theme throughout the guide is that the final GBR should be prepared as late as possible to ensure it comprises the most comprehensive GI data and reflects the latest project layout and requirements. When a GBR should be prepared and the point in time at which it becomes contractual will vary between different procurement scenarios. So firstly, looking at the traditional procurement where a contractor is engaged to implement a design prepared by the employer. Now, this is a simplistic view. Please don't get hung up on the terms I've used or the precise positioning along the timeline. The key point is that understanding of geotechnical risk and design maturity is increasing from left to right. In this case, a GBR can be issued at tender, which incorporates a mature knowledge of the grounds, and the employer may make changes before finalising the GBR based on comments and clarifications from the tenderers. And now if we look at D&B procurement, most of our major infrastructure in the UK and indeed globally is now being delivered on this basis. Again, this is a simplified view, and there are variations on the theme, and relative timings of stages will vary. The key points are that a GBR may be based on limited knowledge at tender stage, but there is typically an opportunity for the contractor to propose changes, and this is really important where the contractor has the latitude to propose alternative solutions and cost-saving innovations. However, the final GBR at contract award will still often come ahead of completion of ground investigation and in advance of detailed design. So these staged GBRs are often referred to as a GBRA, GBRB, and GBRC. We've already sort of touched on the fact that a GBR can be an effective tool for filling gaps in the ground investigation information. So setting a common set of assumptions against which contractors can price the works without necessarily pricing risk associated with those gaps in knowledge. We also had a lot of discussion within the project steering group around the timing of GI data availability relative to when the GBR is written. So, for example, what happens when GI data is continuing to come in, but you've already drawn that contractual line in the sand in the GBR? So a few kind of key messages in this context would be that good practice is for the GBR to be based on comprehensive GI. A GBR should also be produced as late in the project development as possible. The GBR can and should be updated to reflect new information pre-award. So that's between, for example, the GBRB and GBRC shown here. In a design and build situation, an interactive tender period with collaborative refinement of GBR content and risk allocation is recommended. And a GBR should generally not be updated post-award for obvious reasons, it being embedded as part of the contract at that point. So in relation to the GBR, each of the simplified procurement routes presented offer pros and cons. Where the detailed design is developed by the employer, the GBR can be based on all available information and the near final scope of works, but there may be less opportunity for collaboration and a true sense of shared risk. Conversely, where the contractor is responsible for detailed design, there should be plentiful opportunity for early engagement on risk identification and allocation, but at point of contract award, the level of maturity of the design and the knowledge of the ground may be much less. So I'm now going to hand over to John, who will pick up on some of the points raised around conceptual ground models as a starting point for baselines and talk more about drafting and measurability.
Good afternoon, everybody. Good afternoon, everyone. We are slightly ahead of a schedule, so the pressure's on me to keep that in play. What I'm going to talk about really under this heading, hang on, take control. Yes, there we go. So this document is about 80 pages long, and about half of those 80 pages are really on scoping and drafting of GBRs. So I can't possibly hope to cover all of that in this short session. So we're going to focus on these 3 points, and then there's a simple and short Crossrail case study I'll run through at the end of that. And the reason I'm focusing on these 3 points because I think, and you may disagree with me with this, but I think in UK practice GBRs in general over the last 10 years or so, these points are, we haven't necessarily always performed terribly well. So that's why I'm focusing on these today. So if we start with baseline measurability, this is absolutely key. And if we baseline things that can't be measured, there's kind of no point. It isn't really a baseline. And that creates a difficulty because many ground engineering techniques, and bear in mind, I think somebody mentioned this earlier on, Tom, I think, really what I'm talking about here is the encounter, that's an NEC term, between the contractor has between whatever it is he's doing and the ground. And if that goes wrong, we have a potentially adverse contractor, and he may need to think about what the GBR says or what the contract says, data says about whether that's unexpected or not. So in many ground engineering techniques, like in piling, like in close face tunneling, like in ground improvement and so on, earthworks, you don't necessarily get to directly encounter the ground. And sometimes, particularly if we get into earthworks, into ground treatment, what we're doing to the ground changes its properties. So we don't actually get to see it as it was baselined. And so in the past, and I've got many of you will know, I was heavily involved in Crossrail GBRs for quite a long time. I think we have 30 something GBRs. I had a hand in writing and then helping to administer during construction. And so I will hold my hand up here and say, certainly there, and I think in many others I've seen, there's a tendency to put all of these observational difficulties to one side and just baseline the sorts of things you would see in a factual or an interpretive report. And whilst that's the basis fundamentally of what you might put in a GBR, it really does need to be measurable. And I'm certainly aware of examples where this kind of disconnect between measurability and what happens has meant that contractors have had a tough time and not really had any ability to pursue the claim. So so we put this in the guide, this little classification of types of encounter, not as a thing you need to record or formalize in any way, but more as a helpful aid memoir to try and get GBR authors to be a little bit more creative, I think. So in its simplest sense, the important point about this is, and you'll see why in a second, this class 1 to 4, class 1 is the most desirable and simplest form of encounter, and class 4 is probably the most difficult one. So if we start with class 1, an obvious example would be if somebody's digging a big hole and some properties in that hole have been baselined, typically strength of the material, then it's relatively easy to go into that excavation and directly measure, let's say, undrained shear strength. Class 2 is where you would need to measure things indirectly, close to the encounter, measure things in the ground indirectly, such as by doing a little bit of a simple or additional GI. Class 3 is really where you start to get into feedback from whatever equipment is being used, instrumentation or some other thing. Like tool wear is a good example. And class 4 is really conditions that are not actually measurable directly or indirectly. So the alternative here is to baseline ground behaviors in one way. And this certainly, we did this at Crossrail for cross passage excavations, where we were likely to be in very mixed ground, permeable, impermeable, water bearing, not, just because of the nature of where the GI locations were and the cross passages were, we just did not know how the ground would behave. So you would say, for instance, that you would have potentially flowing ground, and that forces the contractor to consider how he might have to deal with that in his tender. And if it turns out to be not flowing, then he's priced for something he doesn't need to build. And if it turns out to be worse than that, then clearly he gets the opportunity to claim. Means and methods is a similar form of baseline, where in that situation, cross passage with mixed, potentially water bearing ground, and you don't actually know what's there, then you could say you will, in the GBR, this cross passage will be built by ground freezing methods. And that forces the contractor to allow for that price, but choose in practice to do it by another means if he wishes. So this is just to repeat what I said right at the beginning of that last slide, is that, so that classification is really just to make people sit up and think a little bit and move away, if they're geotechnical people writing these GBRs, away from the sort of interpretive report type approach, which is often, as I've said, not terribly helpful. But what this means is that whoever's authoring the GBR really does need to know in some detail how whatever the construction technique or the bit of kit is, how it actually works, what its capabilities are, what might trip it up, and what measurement opportunities it presents. And that may even feed into specifying certain sorts of sensors or monitoring on a piece of equipment. And obviously, and there's an example over the page and the next slide, sometimes a little bit of creativity will be required in order to make this work. Here's a very simple example of a potentially different approach. And this has been quite a common one, I think, in the UK. I think every chalk tunnel GBR I think I've seen, including the ones I wrote for Crossrail, says the TBM will encounter a number of layers of flint in the face. Obviously, there's a potential wear issue with that. And there you are, go away and deal with it, Mr. Contractor. But of course, the only opportunity in a closed face machine, a slurry machine like this, to measure is to send somebody into the head and to have a look, rather like this photograph I've got here from Crossrail. Somebody's gone in and had a look and taken a picture. Now that is a slow, expensive, and potentially dangerous thing to do. And actually what it gives us is a discrete measurement opportunity for what is in practice a continuously adverse encounter. So it doesn't work on many levels, and effectively is unmeasurable. So really, maybe the creative thing to do is to change your ground investigation approach such that you can quantify the quantity of flint in any one particular horizon, and that might mean doing things off-site on a field exposure, and then measuring the quantity of flint that comes out of the slurry treatment plant. You know, this sort of thinking sometimes is required. Right, so that's enough of that. We'll move on to conceptual ground models, and I think this will hopefully answer a question that appeared a little while ago around why are GBRs not necessarily based on fact. So I'll come back to that a little bit more in the next slide. So I think the bottom right-hand part of this slide is probably is a key reference, and it was only just published last month or 2 months ago now. And I would encourage you to screenshot this. And if you're not aware of this slide, if you're not aware of that document, go and get it. It's completely free. And what it does is it sets out a succession of different sorts of ground model. And that's what I'm going to talk about for the next few slides. So if you look at that little section there in the middle, and you can see this is taken from a Crossrail drawing. You can see all the different colors, all the different stratas, and you can see somebody's drawn lines on there as a strata boundary, but they don't actually match the strata boundaries in the borehole sticks. Now, why do we do that? I don't really know the answer to that. Do we consider their validity? So those lines are likely to have appeared in a report somewhere. And what do we do about thinking about what is happening in the gaps between individual data points? And whilst we're considering all of those things, you know, the lack of information in the gaps, the uncertainty in the gaps, we need to be also thinking about whether any ground investigation can always tell us everything we need to know. And I think the answer to that is obviously no. And similarly, can any ground models that flow from all of that work, and by inference, ground models that are set out in GBRs, avoid being flawed? And I think the answer to that is also no. So what that IAEG ground models report from the last slide sets up is this succession of ground models that go from conceptual ground model through an observational ground model to an analytical ground model. And that is a very traditional design approach. We're all supposed to do this, for instance, in the UK and in Europe through the Eurocodes. And the conceptual ground model is broadly analogous to a desk study. And that's where if you like, the engineering geologist, probably more than anybody else, sets out what might be there in the ground. And then you can start to think about, once you've established that, you can start to think about construction methods, potential problems with those methods, and so on and so on. You go away and design a ground investigation or gather existing information, and you start to build up what is an observational model based on facts. And then when you come to design whatever it is you're designing, you tend to simplify that observational ground model and focus in on certain design parameters, which are then subsequently factored down, and so on and so on. Cautious approaches in EC7 and everything else. So that doesn't work in construction. There are no additional factors of safety and caution applied. So what you have to do in a GBR is to create a commercial ground model. And because there are these data gaps between boreholes in knowledge, there may be all sorts of things around not being able to get GI kit into certain locations relative to your structure. What you need to do is constantly be feedbacking as data appears in your observational model. You can build up your commercial ground, but you've got to constantly feedback for important gaps to the conceptual ground model, because that tells you what might be there. So that's one aspect of why GBRs are not necessarily based on fact. And the other aspect is that depending on how the GBRs are organized, whether by direction from a client or negotiated, the actual baselines are not necessarily based on, let's say, a reasonable, realistic, or average value of a parameter. That they can be moved around according to the employer's views on risk ownership, or a negotiated view on risk ownership. So that's why this is the fundamental reason why you should never use a GBR to design anything. And here are some super simple examples of why conceptual models can be very important. And the top one is basically London based. That sort of situation you can see there with a sand channel and a fault in some estuarine clays is actually incredibly common if you get deep enough under London. And if your boreholes miss it, then you're not going to know about it. So you have to be aware of that conceptual possibility that you might have those features in the ground, but you might not catch them because they're in the gaps between your boreholes. And similarly, another super simple example, and actually one that is surprisingly common in disputes, is in a glacial till, maybe in a sort of, in old terms, boulder clay. You can't encounter a boulder in a borehole. Boulder's much bigger than a borehole. So how do you account for this wide range of potential obstructions, including some which might be very large, or for all sorts of geological reasons, these things may be concentrated in particular locations. So to deal with that in a commercial ground model and a GBR, you need that conceptual insight. Right. I've certainly been involved in a few projects where I've had to help contractors out with GBRs, where simple drafting errors or simple errors in the geological characterization, and this is really about simple errors in conceptual models, opened the door for the contractor to make perfectly valid claims, but one that the owner or the client wasn't expecting, because he thought he had a pretty good GBR. So the first thing is really you need to check and check again. You need, as Anthony said, a large and diversely experienced authorship team or checking team to get over this. And fundamentally, you need to get that ground model right. You need to get that conceptual model right in the first place. And it's I think near the bottom there, I've said engineers don't normally draft commercial contract documents, which is an obvious truism, but they do draft GBRs. And I think that there's this tendency in the past to try and make them familiar and treat them a bit like interpretive reports. And that's fundamentally wrong. Ands, ors, full stops, all these things are incredibly important. And there's a lot of text in the document in the CIRIA report about drafting and around these issues. Right, simple crossrail ground model example, and this includes mistakes in GBRs. So So that filled in yellow box in the middle is a short SCL tunnel underneath Moorgate in the City of London, if you know where that is, and it links that yellow box off to the left, which is a nearly 40-meter deep shaft, with an escalator tunnel on the right, which goes down to the platform level tunnels and the running tunnels you can see in red. Super simple ground model, conceptual ground model for London. Which anybody probably in this meeting could probably produce, is over on the right. So Mayground over alluvium, over some river terrace deposits, sand and gravel, over some London clay. And you can see that circle there is where this short length of solid yellow SCL tunnel sat. Now, if you know anything about tunneling, you would know that SCL and sand and gravel, permeable sand and gravel below the water table is a difficult thing. So by the time, if you just concentrate on the left-hand side of this slide to begin with, by the time we got towards the end of the ability to get data, GI data for these two particular contracts, we only had those 4 boreholes on the left. And this is mainly because there were buildings in the way which the project needed to demolish, and the impossibility because of all the services and sewers in Moorgate of doing any boreholes in the street. So we had that information, and you can see those contours there on the top of the London clay. And we've got this massive hole, which is not entirely unexpected in London, but that's a different presentation. Massive hole, effectively full of sand here. And so the GBR at this point, effectively that observational model was turned into a commercial model in the GBR by baselining increased thickness of the river terrace deposits in this area, and specifically in that SCL tunnel, because that's where it was going to be difficult to deal with. Digging sand out of the big box on the left rather than London clay is not really a particularly onerous thing. So on the right, the construction approach that was required at tender based on this conceptual and commercial GBR model, and it's conceptual in this location because we didn't have any boreholes, was fundamentally to grout up the river terrace deposits, the sands and gravels above the tunnel, and then also to add a pipe arch where we were breaking into to mine the tunnel from the box. And you can see how difficult a location is. We have a fairly significant sewer just in and around the permeation zone. We have beneath this SCL tunnel, we have 2 running tunnels for the Northern Line, and then we have all the crossrail tunnels all around those things. So and we have the D-wall and the excavation for the box on the left as well. So it's a very critical location. And we have the Electra House above this tunnel, which was a fairly delicate building. It was still in use. So by the time we did all the grouting and we got a lot more data, and then by this time we'd also demolished the building above the box and started to dig the box out. So we gathered lots and lots of data post-contract award, and that's what this big hole looked like in detail, still full of sand. And you can see that where the start of our tunnel is, we thought we had almost a full face of sand and gravel full of water, which we thought we grouted up. But when we opened up, what we actually found was a whole load of clay sitting on and with little sand channels in it, sitting on the London clay. And those blue lines, actually, you can see on there, not blue in practice, we just coloured those in. They are all the grout we thought we were permeating into the sand and gravel. So clearly we weren't. So this is actually less onerous than finding all the sand and the water, but it's clearly a failure of the conceptual, it's a failure of the conceptual model. And what happened here was actually the GBR, because of the way it was phrased, said that the river terrace deposits would have some clay in it. And clearly there's an awful lot of clay in it. But on the face of it, there was no opportunity for the contractor to claim for all this time and effort he'd had to put in to unnecessarily grout up. But actually there was, so that might seem like an excellent result for Crossrail, but unfortunately there was an error in the drafting of the GBR in that thicknesses and elevations of this river terrace deposits were baseline twice, and there was an inconsistency between the two. And that's something, if you're getting into authoring GBRs, you have to be very careful about. Never baseline anything twice. It's so easy to make a mistake. So a claim was possible, but in practice didn't arise because there were a whole lot of other issues with other aspects for this particular contract, which meant that the contractor got paid through a supplemental agreement, but he didn't get paid through a compensation event directly. So, final slide from me. Baselines must be measurable. If you take one thing away from this presentation, or certainly from my bit, please remember that. And when you're drafting, always keep that conceptual model, that what might be there thing in your mind when drafting. And because I've seen lots of horrible, silly mistakes in GBRs where contractors have managed to extract large sums of money out of their clients, you really do need to check, and check again. Thank you very much. So now I would like to pass on to Imran to talk about all the sorts of things we can apply GBRs to other than tunnels.
Thanks, John. So I was just going to start with sticks. So I went and looked at this report, and it's quite important to just highlight some of the facts that that they have used to come up with some projections on what could happen on the UK infrastructure projects in the next 10 years. So this report was written in 2019. And at the time of this report being written, there was nearly £600 billion worth of infrastructure work planned for the UK. And what the study showed is that nearly 80% of UK infrastructure projects run over budget due to poor planning. And that equates to about 19 billion every year, which is roughly 30% of the overall cost that would be incurred on these projects. And there were a number of conclusions in this report, but it's two that I would just wanted to highlight. One was that poor predictive abilities of project teams in the early stages, that leads to cost overruns and delays, and then procurement based on cheapest price. And I think it's worth highlighting that a lot of these can be related to mismanagement of ground risk in these projects. So the other speakers have illustrated why GBRs could be a good risk management strategy to deal with ground risk. But I thought I'd just use that as a starting point and just go into some of the examples of the various different applications of GBRs that can be used to make the projects a bit more manageable in terms of ground risk. Now, we know we've got a lot of history of using GBRs in tunneling projects, and probably more recently in piling and retaining works. But as the industry has started using more GBRs, we're starting to see there are a number of examples of what can cause delays in these types of projects. And in terms of piling and retaining works, a poor choice of construction equipment to construct the piling or dewall work or excavation of the materials can lead to delays and potential overruns, and strategies of managing that, and especially using GBRs would be one way of doing it. I'll illustrate this a bit more in an example that I've got later on. Similarly with earthworks, we have a number of projects where you can have a misunderstanding or lack of recognition of the type of foundation soils that will be encountered, leading to inappropriate choice of ground improvement techniques, or not recognizing the appropriate material reusability classification, and therefore leading to a mass hole imbalance. And then similarly, we have a few offshore projects that we tend to focus a lot on the foundations of offshore, the offshore structures or the wind farms, but not necessarily focus on the ancillary works like cabling that goes to these assets, which then again can lead to a lot of overruns and cost delays. Now, what we have illustrated and talked about in the presentation so far is that there are ways of taking the data that we have to identify the intrinsic properties of the ground and be able to create or define baseline conditions, which then help with managing the ground risk through a GBR process. But just to illustrate that, I thought I'd use an example of something that I've dealt with in the past, and John's briefly touched on this as an example. So this is just an example of a glacial soil project where the cause of the delays led to some cost and program overruns. But just as I said earlier, biggest delay in piling and D-wall construction is usually inappropriate selection of construction techniques. This could be caused by insufficient GI, inexperienced contractors, or ground investigation models skewed towards establishing the designs. Now, in this example, this is a bridge foundation where the designer took the information they had, came up with a ground model that was based on the boreholes that were available. They developed the bedrock, defined the pile penetration to be terminating on bedrock, with a potentially cautious estimate of ground parameters. Probably it can be said that this is a good theoretical design, but probably wished in place, but has some inherent risks, which the designer has highlighted in the risk register. However, when the contractor comes to look at this to select the construction options for this ground conditions, they have to look at the conceptual ground model, which is flagged in the risk register, not in a GBR on this project. You could have, as you do in glacial soil, some sand channels, possibly some faults. You may have some glacial lacustre deposits. And then, as John briefly mentioned, you can have cobbles, but also you can have boulders in there. Now, for the selection of the piling technique, there's a myriad of potential ground risks in this situation. The contractor has to consider whether they can use CFA, case, thin wall, or segmental casing, pre-augering of the ground, or larger capable of drilling into the rock. In this situation, the piling contractor selected a case and augered pile with a thin wall casing. However, the selected rig was chosen to be not sufficiently strong to get through boulders and or rock. What transpired in this project was that the contractor had this choice of whether he goes with a high price with low risk or low price with high risk. They selected a low price with a high risk approach, so they did not have a technique to deal with with any ground risk if they encountered them in this situation. Now, on a project like this, you will have a contractor and a subcontractor, and when they encounter a problem, you can have some contractual difficulties. And in this project, what transpired is they actually did encounter some boulders. They did not have the appropriate tools to be able to deal with the piling through the boulder. It led to some delays. The actual cost of managing that risk on site would have been pre-drilling, which is what they eventually had to do. However, because of the risk allocation and the dispute resolution wasn't established, there wasn't a GBR, the amount of time it took to deal with this as a situation led to a situation where the actual program was delayed. The actual program delays would have been substantially higher than the cost of dealing with the obstruction or the boulder. So I would go back to what Randy said earlier. If we had in this situation either more GI to be able to establish the presence of a boulder, or have a process that allows some cost to be allocated to the known unknowns, which in this situation could have been a known unknown, that would have helped deal with this as a problem. And the GBR guide provides this type of information to help us with this risk allocation going forward. Similarly, in earthworks, we have a number of scenarios and things that we have to think about, which would lead to potential delays and cost overruns. We have to recognize that foundation soils and the type of foundation that we will deal with, whether it's cutting or embankments. mass haul and reusability of materials, slope angles and groundwater. All of these things, if they're known, will lead to a good construction method being selected. However, there's some unknowns related to these. There can be some delays, and providing some baselines would help with these situations. So I just wanted to, again, show an example which is related to mass haul, and we all need to recognize that sustainability and cost considerations are paramount in mass haul, and especially nowadays we have to take it quite seriously and apply that to our designs and our solutions that we use. Clients and designers and contractors should be looking to limit imports, reduce double handling and lorry movements wherever possible. So this, as an example, is an earthworks where the solution of balancing the earthworks would require the materials to be treated, because you cannot get from the cuts class 1 or class 1 materials or better, but what you can do is get class 2. However, the earthwork specification is such that the treatment of the earthworks is required. What the bottom figure shows is that you can have total potential sulfate in these earthworks that could exceed the 1% in a small localized area, which would preclude the use of treatment of this material to be reused for the embankment. Now, this is a situation, again, as highlighted earlier, that we could use potential consideration of either having a allocation for dealing with situations where treatment, if the material cannot be treated, the costs associated with that can be managed through the GBR, or alternatively, you could quarantine parts of this earthwork to provide GBR statements that are related to those areas, helping the contractor by managing the risk as they proceed with the construction. There are a number of measurable properties in the soil that can be used to provide baseline. There's a list of these in the GBR guide document. Atterberg limits, chemical content within in situ soils, groundwater levels, moisture content, etc., are directly measurable and can be used for baselines. Next, I was going to move on to just some consideration during construction, that just some highlights that we've listed in the report. Just the first thing to highlight is the GBR is a commercial document associated with risk allocation. It is not a risk mitigation or risk management document for design, and should not be used for either design or construction and or health and safety. The second key thing to keep in mind is the burden of proof of baselining or is with the contractor. So the contractor has to show that the encounter conditions are worse than the baseline statements. And then not only that, but they also have to then be able to demonstrate that there's a consequential increase in cost or time which the contractor should be compensated for. I think one of the key messages for people to take away from this document is we need to have collaborative processes early on in the use of GBR. You should not wait till there has been a adverse encounter to deal with the problems. Having a transparent data management strategy that's is a collaborative process between the contractor, client, and the designer will help with potential disputes, and also have clear communication channels to allow for these to be managed during construction. One of the questions that does come up is progressive updates. Once the contract is awarded, a GBR is a contractual document. However, Anthony's just shared some examples of where there are some mechanisms pre-construction stages where progressive updates can be made. And then finally, having the right personnel to manage the construction process is fundamental, and a conversation and a discussion should happen at early stages to recognize who is going to measure it, who is going to submit the compensation events, what type of dispute resolution board or mechanism needs to be put in place to manage these as we go along. Finally, just some selected conclusions from the presentation and also from the report. GBRs are a good thing to be usefully applied to much smaller and simpler projects than at present. GBRs can greatly simplify dealing with unforeseen ground conditions during construction, and we've provided in the documents guidance on using it through an NAC. Baseline must be realistic. Again, what John was it should be measurable and measurable safely. And finally, drafting errors can be very expensive. Thank you very much.
There's a lot of comments and questions that have come in that helpfully our panel have attempted to answer as they've gone. I'm not clear whether those are then invisible to the rest of the audience, so we may well end up dipping back into some of the questions that were typed earlier that have may have disappeared from your thing. Tom, do you want to kick off?
Yes, thank you very much, Andy, and thank you very much to the panel for their wonderful presentation. I'm going to try and go through these questions in the order that they came in. I might diverge from that, but yeah, I think so. Thank you for everyone who has put their questions in. We've had a good load of questions already, so that's great. Do keep them coming in. Gary Walker submitted a question about expanding on the statement from the need if a baseline deviates from fact. I think that's been answered, John. So I think we'll move straight on, and maybe I can throw this one to this next question to Anthony. Anthony, if you want to also ask someone else to contribute, please do, and others. But it's from Frank. So how do we get clients to see the value in spending more upfront? I.e. one way or another, they'll pay for a ground investigation.
Yes, thank you. So, I mean, I know Randy has provided a response here and referenced some of the earlier reports that deal with this issue directly. And Randy's probably got some other things he was going to say. But I guess, I mean, this is something in the geotechnical industry that has always, certainly as long as I've been involved, has always been an issue. Clearly, we have some very well-educated clients now who are spending a lot of money on ground investigation. And to some extent, I think on those big projects where a lot of money is being spent, the problem has become more about the timing of that ground investigation than the quantum necessarily. But it's I think it's tackling the procurement teams within the client organisations that seem to be, for me, where this gets stuck. You know, if you talk to technical counterparts within client organisations, and obviously I'm talking about the bigger client organisations that have technical departments as well, then I think the value is known of spending the money up front. But what I see the challenge is, and I guess particularly maybe on some of the sort of overseas jobs that I get involved in, is that there's a project development cycle and the capital expenditure that's needed up front in some of these projects prior to commitment to those projects being either granted planning or knowledge that they're going to be technically feasible, is a stumbling block. And so I think we maybe can do more in enhancing the value of the sort of early survey, desk study, walkover mapping components that offer lower cost but good quality information. Phasing of ground investigations, recognizing that we need to almost match the spend profile that clients are willing to spend. So some of those things I think can help. Randy, did you want to come in on that?
Yeah, there are 2 points I'd like to make. The 1984 report that I referenced involved the review of 200 construction case histories of tunnels around the US, North America, because some Canadian works were involved. The purpose being to assess the level of investment in SI as compared to the incident for claims and disparity between as-built cost versus bid cost. And there are a number of different variables, independent and dependent, that were utilized to show the phenomena. One was how many lineal feet of borehole per lineal mile of tunnel was appropriate. And so it was represented in a lot of different ways, but the bottom line was, if you're not spending 3% of your planned construction cost on SI, you are going into a red zone. Because of the pure lack of information that you have to judge, irrespective of how well-defined you think the ground model is going to get down to details, the more you spend understanding the ground, the better. And for my money, I don't think that report, that study, has an equivalent that I've seen anywhere in the world. And I think the data still bear on it. The other point is that in the world of design and build, what I'm seeing is a trend where owners are focusing on SI to direct more toward the design development and project configuration. And they are short sheeting the properties that contractors need to provide to estimate cutter wear or hyperbaric intervention or soil conditioning. And what happens is the constructability properties are coming very late in the day, if at all. Two imbalances where, if we're planning an SI effort, let's try to be fair about what we need for design and what is critical for constructability and estimating, and make sure that we're putting the right investment in. Otherwise, you just increase the risk of having an ambiguity or a claim.
Okay, thank you, Randy. John, do you want to come in on this?
Great question, Frank, and hello. Very simply, I think the big picture question is that we all need to write more case studies, and in particular, we need to write case studies about things that go wrong. I think that's what's missing. So, client A doesn't know what client B had to put up with and how it was dealt with. So I think that's something on all of us, really, and it's with contractors and consultants and clients. Be a bit more open and write these things up.
Hey, Graham, thank you very much.
Do you want me to have a crack?
Yes, please, yeah. Andy, if you've got one.
Yeah, I'm conscious that John did the piece on measurability, and there's a question from Reza here, which Randy has attempted to answer in the text, but I'm going to put it back to you, John, given it was your section. In terms of measurability classifications, what if the various parties have different views on measuring method in terms of accuracy and cost? And I guess there's a follow-up on the chat. Can you elaborate on the how?
The how to measure.
Yeah,
yeah, okay, that's fine, Andy. First of all, GBR really should be defining methods of measurement, practical, and possibly also frequency of measurement for things that might happen in a flash and are gone. So you've lost the opportunity. And secondly, methods of measurement can be difficult. So I think you can define all the methods you can think of, but it's worth considering having a sort of fallback position where you say, or some other method of measurement agreed between the employer and the contractor.
Okay.
Thank you. Randy, did you want to supplement that at all, given that you had a crack in the text?
Yes, I've seen two approaches. One where if there's a dispute, the parties should get together and decide at that time, given the nature of the dispute, what measurable property or condition will be sufficient to convince the parties that there's either entitlement or not. That's item one, because we're guessing at what the DSC or the variation might be, and nevertheless, I've been involved in a large P3 program where the lawyers wanted us to pre-specify what the extent and scope of data gathering would be to test the veracity of every baseline presented in the GBR. You're guessing at what you think the variation will be or what the circumstances will be. In some cases, if it's ground behavior, it may not be a physical test, it may be a videotape of observing the instability of an SEM heading? We don't know, but this is why I feel maybe it's a blend of the two. But as John says, if the parties can agree on what information is warranted to resolve the dispute, and it requires some discussion at commencement of the dispute discussion, again, it takes both sides.
Imran.
Yeah, just to add, I mean, having a dispute resolution board or team, if you can't resolve the differences, having a third party getting involved in those discussions early also would help.
Okay, thank you. I've got another question, probably best for John in the first instance. Thank you, Gary. With reference to the IAEG sticks, what happens? I know it's a tough one, isn't it? Tongue twister.
I got it wrong.
What happens if the assumed dotted lines for strata in the GBR conceptual model are not the case, but the GI in the contract is correct? What would govern a contractual claim, the GI or the GBR? So I think it's the
well, okay, so let's just talk about this because it's simple in a normal amended NEC contract format. So if an adverse encounter arises and it is covered in the GBR, so let's just say this material is going to have this no more than this strength, and it turns out to be more than that, then regardless of what the GI says, the GBR is used to test that potential claim. If it's something that sits outside the GBR, this adverse encounter is something for whatever reason, a lack of GI or something else, there's an encounter that isn't covered in the GBR, then the test data that would be used against would be a traditional reasonableness test that you might have found in ICE contracts going back to the year dot. So, but that uses the ground investigation information in the contract as a test. So the two things, the GBR and the GI info in the contract, are never ever used together. So there's a hierarchy, GBR at the top.
And thank you very much. There is a question here in the chat about the Emerald book. There have been some answers in the chat. I was wondering if maybe Randy, you'd like to maybe summarise, and Anthony, I know you've responded as well, maybe summarise the responses. The original question was, in the Emerald book contract, any ground conditions that is not foreseen and covered in some way within the GBR is deemed to be unforeseen from a contractual perspective and subject to potential claim on the client. Does the guide have any similar approaches? So thank you, Christopher, for your question.
Yes, and I'll say that the ASCE update has a chapter on legal and contractual considerations that hits this point specifically. In helping to write the Emerald book, I'm chagrined to say that the document is coherent except for the definition of geotechnical baseline report. That's it. Everything else hangs together, but the geotechnical baseline report is defined as being the sole singular definition of foreseeability. And that can't possibly be the case. What we've had in the US is contractors taking that expression from a different contract, a form of contract, and they're trying to apply it to a dispute in the US with a different form of contract and saying that the converse is therefore a basis for a change. Anything that is not mentioned in the GBR is a basis for additional compensation. That's an unrealistic and inappropriate conclusion to draw, and they've tried and they've lost in the courts. But we try to be as clear as we can at the outset. A number of us have had discussions with the TG10, the group of FIDIC and ITA members who developed it, and perhaps in a subsequent edition of the Emerald book, there'll be an amendment or two.
Thank you,
Yeah,
Anthony.
so the only thing I'd add to that really is I think we kind of tackle this in the CIRIA guide where we talk about what's been termed the universality of the GBR. So one of the recommendations that I guess comes through in the guide is that we don't want the contract to be silent on risks. So the GBR has a defined scope. We acknowledge that there will be items that are not covered in that scope, and therefore the contract needs to address, well, what happens to those items. So there's flexibility on how people want to deal with them, but what we're saying is if you remain silent, then that either produces ambiguity, or in precedent case law, then it probably diverts to being the contractor's risk. So I think it is an area where there's some divergence between what we've said and the Emerald Book on that basis, because this idea that if it's not in the GBR, then it's unforeseen, suggests that the GBR is then deficient if it doesn't capture something. And I think with the best will in the world, we're not going to write GBRs that cover every eventuality, and often we set out deliberately not to do so. Some of the GBRs that are produced in the UK are quite focused to address the key risks, so that doesn't really fit within the Emerald Book context. So yeah, I don't think there's anything in the CIRIA guide that contradicts the Emerald Book as such, but that is one area where our recommendation is slightly different.
If I can add with one example, one of the philosophies of the GBR is that it's not intended to replicate the contract. It's a roadmap, and you describe the relevant conditions and behaviors, and then make reference to the species or the payment provisions for quantification. Let's say there's a hard rock TBM and groundwater inflows are anticipated, and the GBR talks about rock mass permeabilities and discontinuities and what have you. And the provisions for formation grouting based on thresholds of inflow through a borehole or a probe hole are contained and described in specification blank. And the quantities of grout that are to be contemplated are identified in payment provision X. Well, in that instance, you can't possibly say that the GBR is the sole predictor when there are key quantification elements and requirements in other elements of the contract. It's one of the reasons that in the US, the basis for a claim is that you've encountered a condition that differs from an indication in the contract, which can occur in different places. Unfortunately, Emerald Book says the sole predictor or indicator is the GBR, but in my view, if you've estimated 5x quantity, or if you've anticipated X quantity of formation grouting, and you've had to go to 5x formation grouting, the contractor is entitled to something other than an extension of the unit price because of the disruption to his construction program. So the exceedance of a planned quantity, I think, is an indication of a variation or a differing site condition. And it occurs somewhere other than the GBR by intent.
Tom, could I just perhaps make a point? Talib, Dominic Molyneux, around restating the fact that the GBR is intended to assist with dispute resolution. It's a commercial document, not a technical one. But contractors are driven through commercial necessity, and separating their operations from what they're doing is based on the baseline. So how there's a temptation to ignore factual data there and make provision for what's set out in the GBR. How does industry overcome this temptation? How do we work better together? I'm not sure who to point that at, but if anyone wants to put their hand up, feel free. Go on, Randy.
So one of the contract provisions that was espoused back in the 90s was something called escrow bid documentation. And it was the basis for how the contractor translated the indications in the GBR into the pricing of the work. And most of the contractors in the US fully endorse the use of escrow bid documents, because if they've got a valid claim, the proof of how they transferred the data into the production rates and the utilization rates and the downtimes are in those escrow bid documents. And they would like to encourage a dispute tribunal to identify. If the UK practice hasn't utilized escrow bid documents before, I think it's worthy to try them and not simply say, we don't use them, therefore we're not going to consider them. It has value because it helps to fill this gap between what data did you assume and how did that convert into production rates and downtimes and TBM availability and utilization, et cetera. So it helps fill a gap.
And excuse me. Thank you very much, Randy. We are running out of time, but I think there's time probably for two more questions, one from Andre and one from Dave Jones. We'll quickly go to Andre's question. And I think this is probably for you, John, as he was referring to the flints in the GBR. So the example of flints versus GBR illustrates the challenges of writing and implementing an effective GBR. The impact of flints on tunnel productivity, GBM wear, depends on the combination and permutation of a myriad of factors, including but not limited to size, shape, frequency, orientation, abrasivity, etc. These factors are theoretically unmeasurable, but in reality, it's impractical. Certain class 1 tests like Kershaw abrasivity tests got such a long leading time that they are incompatible within the contractual time frame to apply during the work. So for a change, it's often impractical to inspect the face and the cuttings provided, which provide only a fraction of the information available. Nevertheless, GBRs often cover flints. Any comments?
Hi, Andrea. Thanks for the question. There's a lot in there. I think there's probably no perfect solution to this, or not even one that's even close. But I think at least attempting to measure measurable things is a step in the right direction. So some of these things, I think that certainly the CIRIA point, I think, don't generally get picked up very well in GIs in this country. So there is in a broad sense, there's an element here, and I think I mentioned this, where we need to be collectively as an industry focusing ground investigations as well as focusing on design. I should say we should be focusing them on things that could go wrong in construction. So we have a basis, a factual basis to try and address these things in a GBR. What else have we got in this question? Excuse me when I read it again. And I think the other point that's kind of lies behind your question is that, and I think this lies behind one of the other questions as well, is that the GBR has two purposes. It has the stuff we're talking about here about managing claims and assessing claims. But the other point is that at tender, everybody knows that they are going to be presumed to have accounted for the GBR in the fullness of time. So all of those variations you might get, for instance, in the design of a slurry TBM, the contractor the tender is entirely free to use the GBR as a basis for pricing or not. But the point is he will be assumed to have adopted it. I'm not sure whether I've gone off the point there or not. But I think fundamentally that the GBR is not a panacea. I think this is a more general point. But what it does is it's a huge step in the right direction if we get a well-drafted one in terms of clarity of who owns what. In detail, there are still some very difficult problems, but they existed anyway.
Yeah. Okay. Thanks, Anthony.
Yeah, thanks, Tom. I was just going to add to that. I think so. As the industry moves more towards sort of more collaborative contracts with enterprises and alliances, things like that, I think we may see more opportunity to introduce baselines that are more aligned with the impact of the physical conditions as opposed to measuring physical conditions. So, I mean, I think we say in the guide, and I agree that the priority needs to be where we can, we measure physical properties of the ground. But in this case, you know, maybe the impact of the physical property is rate of wear and hence frequency of disc changes requiring interventions. So there is an option if you've got the relationship between client and contractor that allows you to do so, to baseline the frequency of interventions, for example.
Thank you. Maybe Anthony, you can have a first stab at this this next question from Dave Jones, and if not, obviously pass it on to one of your other colleagues. How should contractors and employers view popular target cost contracts with pain gain mechanisms having a part in the ground risk sharing approach from ground engineering projects with or without a GBR, perhaps noting the apportionment of pain share if there is a cost overrun? Okay.
So I mean, at a basic level, I guess the GBR would typically entitle a contractor to an increase in the target cost or time for completion. So in that sense, I think the GBR is still a legitimate mechanism to do that. And obviously the contractor is going to have an interest in maintaining his fee proportion rather than going into the pain section. So I think GBRs are perfectly valid in that scenario.
Perfect, thank you, John.
Yes, just let me reread David's question. How should contractors and employers view popular target cost contracts? Well, with pay and gain mechanisms. Well, clearly, pay and gain mechanisms are another way of sharing risk other than GBRs, but obviously they're not GBRs, and there's documents about GBRs. One thing I have come across recently, David, is well, a few years ago actually, and it just cropped up again in discussions about a GBR this week, is it's one thing that is maybe a little bit innovative is you could have a GBR at tender stage, which established the detail of the pay and gain mechanism around particular encounters, and then that GBR could fall away as a contract document, so you could effectively use it as a pricing mechanism. And I certainly know of one, and I'm not going to name it, one very large tunnelling contract in this country where exactly that thing is being done. It's not in a pay and gain contract, but it's a GBR was used to establish a fairly traditional ground classification payment system. So there are opportunities to use GBRs outside contracts as well.
Thank you very much. Andy, I notice it's nearly 10 to 4 now, and we do have a summary slide. Do you want to go for potentially one more question from Talib?
I'm just conscious that John is endeavouring to answer Talib's question.
I am, yes. Give me a minute, Talib, and I'll ping you an answer.
I suspect in the interest of time, it might be worth just if Susan can flash up the last few slides. Tom, if you could say a few words of summary, if that's all right.
Yes, of course. So first of all, I want to thank all the presenters today. They've done a great job, and obviously thank the people for attending. But in summary, I think there's some really interesting key points that we take away. Some of them are fairly basic, and some of them are a little more complex. In the first instance, GBRs are a contract document. That's it's been said a number of times, and it's definitely worth reiterating. Again, there was some really useful guidance from John on baselines being realistic, in that exceeding them is actually plausible, and baselines are measurable and measurable safely, and we've had some discussions around that in the chat as well. I think the other thing which is really important to note is they're not just for tunnels. We've had Imran did some really good examples of how they've worked on piling projects, on earthworks, and touched on the wind farms. So really helpful guidance there to expand the use of GBRs outside of tunnels into the rest of the industry. And actually, GBRs, hopefully we've been able to demonstrate that they're really useful. They're a really useful tool and can be applied to not just different types of engineering work, but also different scales of engineering works. And actually, there is some real value in using GBRs on, so say, some smaller projects, and not just for the big, for the big projects as well. And I think also we've been able to demonstrate that a number of people are required to input into this. It's not just the ground engineers. There's obviously a lot of involvement from owners or organisations, and the multiple different disciplines within the ground engineering and beyond team to make an effective GBR for everyone. And I suppose the last point I would maybe like to make from the conclusions again was, drafting errors, as Randy, and others have said, can be very expensive. So check and check again, as John said. So I think from my perspective, it's been a really good event. So thank you very much, CIRIA, and also it's been really useful and really interesting. So yeah, so thank you very much. And Andy, over to you.
Yeah, thanks very much. Just wanted to echo Tom's thanks. We put up the slide earlier with too many names to name individually, but this goes well beyond the author team and Tom, who's acted admirably as project steering group chair through the process. It really has been a collaborative effort. So I just wanted to say thank you very much to obviously everyone who's participated today as well. Thank you for your questions. We will endeavour to get back if we've not adequately answered any of them. And I know John's in the process of typing away to Talib, who had an outstanding issue. It just remains for me to say, Susan, would you mind moving the slide on? I've just got a little advertorial, I suppose. I mentioned at the start that CIRIA is obviously reliant on sponsorship contributions for guidance such as this. And I just wanted to flag a number of projects that are ongoing or in proposal stage that kind of interface with the geotechnical community. We've got ongoing work on the piling guide, which is led by a consortium of authors from Coffee and beyond. Tunnel asset management, which is again another Mott MacDonald production, which is mid-flight at the moment. But we've got a couple of proposals which are really on the starting blocks, which we are in the process of banging the drum for. One is on engineering in chalk, which is an update to an existing CIRIA publication. And the other one is on geosystems, which is an update to a piece of work which was originally produced by RAP. And we're looking to update that given advances in technology and approach and case studies more recently. So if there is any of that appeals to the community that's online, please feel free to get in touch. We'd love to have you on board to share your expertise and be part of the CIRIA development process. But thank you very much, everybody, for your participation today. Thanks very much to the panel once again. Hope you've enjoyed it. We will, obviously, there's been a recording today. The slides and the recording will be circulated in due course. But thank you very much, everybody. Bye for now.